Good day, I'm Queenie, and in this video presentation, me and my group mates will be discussing the different type of sets with the aid of mathematics instructional materials supported by technology tools. In my part, I'll be using mathematics instructional materials supported by technology tools, the PowerPoint presentation, and I used Canva for one of my illustration in my discussion. So I will be the one to discuss the first type of sets, and it will be the infinite set. So it is also known as countable set. It is a set which contains a definite number of elements. So it means na the infinite set is just we can identify infinite set if the content of the set is countable and have definite elements. And here are the few examples of infinite sets. So the first one is the set P have an element of 0, 3, 6, so on and so forth, 99. So we can tell that it is an infinite set. It is an infinite set, that P is an infinite set because the element contains from 0 to 99 and it is countable. The second example is the set Q, where A is an integer but A is greater than 1 but less than 10. So it means the elements of the set Q ranges from 2, 3, 4, 5, 6, 7, 8, 9 because A is greater than 1 and A is less than 10. And it is an infinite set since 2 to 9 is countable. So this is also another example of an infinite set. The list of English alphabet. So we can say that the list of English alphabet is infinite because it consists of 28 letters, no more, no less, and it's countable. So that's my part for the infinite set. Thank you.
Hello everyone, I am Elmi Bolos and now I'm going to discuss about infinite set and subset. So first we will going to discuss about infinite set. So an infinite set, a set which contain infinite number of elements is called an infinite set. If a set is not finite, it is called an infinite set because the number of elements in that set is not countable, and also we cannot represent it in a roster form. Thus, infinite sets are also known as uncountable sets. So the elements of an infinite set are represented by three dots or the ellipses. Thus, it represents the infinity of that set. And we have here an example of infinite set. So, for example, a set of whole numbers. So, a set of whole numbers we have here 0, 1, 2, 3, and 4, and so on. So, the ellipses symbol, which what I have said earlier that ellipses represent the infinity of this set. So, we can say that the cardinality of this set is infinity. So when we say cardinality, the number of elements in this set. So because because in the example it said that the set of whole numbers. So we can count the elements in this example because it is not countable, it has no ending, it is continuous. So we can say that the cardinality of this set is infinity. And now let's I mean Actually, there are a lot of examples of infinite set. For example, we have a set of all points on the line, the set of all integers. So when we say the set of all integers, we can count all the all the integers. It is uncountable, so it is infinite set. A set of all natural numbers. Those are the examples of infinite set. Now let's move on to subset. Subset. A set X is a subset of set Y if every element of set of X is an element of set Y. Set E is said to be subset of set B if all the elements of set E are also present in set B. In other words, this set E is contained inside B. The subset of any set consists of all possible sets, including the elements and the null set. And we have here an example of subset. So first we have let X is equal to the set of 1, 2, 3, 4, 5, and 6. And set Y is equal to the set of 1 and 2. So in this example, we can say that set Y is a subset of set X because all element in set Y is present in set X. So which is set Y is contained inside set X. And we have here a second example. If set E has X and Y, a set of X and Y, and set B has a set of X, Y, and Z, then E is the subset of B because all element in set E is present in set B. And that's all from my part on this discussion. Thank you.
Good evening, everyone. Tonight, we will going to discuss what is proper subset and universal set. If we were going to say proper subset, a proper subset is where the elements of one are entirely contained within the other set also contains more items. For example, set A contains the element of 1, 2, 3, 4. And set A contains and set B contains an element of 1, 2, 3, 4, and 5. Set A is the proper subset of set B because set A contains the element of set B, which is set B contains also the element of set A. Set A and set B contains more elements than the set A. So, kung ato nyo siya i-explain, kibali ang proper subset, ang other set, kibali, and one set, the other set contains all the element of the one set, but that set has contains more elements. Mga proper subset rang is ang isa ka set if tanan element ng adto na set is present sa proper subset adto na set, and the proper subset also contains more than the elements of the other set. Another example, set A contains the element of the negative integers. And set B contains the element of all integers. So, set A is the proper subset of set B because negative integers are considered as integers, and the set B contains all the integers. We're going to say all the integers. It contains the negative and positive integers, which deals that the proper subset of set A is set B. Okay, next we're going to discuss about the universal set. Universal set. If we're going to talk about universal set is the set of all elements. For example, in this diagram, we have here the set A, the set B, and the set C. Then what do you observe? So if we're going to say universal set is a set of all elements. So in this diagram, set A is the universal set of set B and C. So simply as that, kibali ang duha ka set or more than two sets, kibali ang ila universal set if their all elements are present in a single set. Another example, let's say set A contains the elements of all integers. So if I say, and set B contains the element of all negative integers. And set C contains the element of positive integers. So, in this way, set A is the universal set of set B and set C. Why? Because negative integers and positive integers are all in set A, because set A contains the all integers. If we're going to say all integers, it's either both or positive integers are present in that set. Simply as that, universal set is the set of all integers if all the integers of two or more sets are present in a single set. That means that set is the universal set of all sets. That's all.
So, hi everyone. So, my name is Nova Mayfer Cadilla Mausisa, and I am the last presenter, and I will be going to discuss equal set and equivalent set. So, the technology tools that I used for this discussion is PPT, of course, the most common and useful technology tools. So this is now the slide for my PPT. So we are going to discuss what is equal set and equivalent set. So here we can see the differences of these two. So maybe some of you got confused. What is the difference of equal to the equivalent set? So here we are going to discuss it. So even though equal set and equivalent set sounds like there isn't much difference between them, these two, the equivalent set and equal set, are similar concepts, yes, but there is a minor difference between them. the sets them both apart. But before we divide into equal and equal sets, or we are going to discuss the difference of these two, let us understand first what is cardinality, because later on we are going to represent cardinality for their differences for us to be, or for you to be able to understand the lesson. So when we say cardinality, it is the number of elements excuse me, inside a set. So again, cardinality is the number of elements inside a set. So now, this is important again because this will help you understand the difference between equal and equivalent set. So next we have, so now let's proceed to equal set. So it is stated here that equal set defined as the sets that have the same cardinality and all equal. So again, I'm using the word cardinality. So when we say equal set ko, no, is the set that have the same cardinality and all equal elements. So same cardinality and same elements inside of the sets. So again, when we say cardinality, it is the number of elements inside a set. So next, it's stated here that if two sets contain the same elements, they are said to be equal. So the sets, alright, so two sets A and B can be equal only if each element of set A is also the element of the set B. Set B. Also, if two sets are the subsets of each other, they are said to be equal. So we have here an example for you to be able to understand what is equal set. Okay. So we have here two examples. So if A is equal to 1, 2, and if set A is 1, 2, and 6, and for the set B is equal to 6, 1, and 2. So what have you observed from the example? So as you notice there, from example number 1, it has the same cardinality. Again, when we say cardinality, it is the number of the set, or of the set. So we have 1, 2, 3, and for the set B is 1, 2, 3, and they are equal as every element of set A is an element of set B. So as you notice, sa set A, we have 1, 2, and 6, and for the set B, we have 6, 1, and 2. Although wala sila magkapareha ng order, but they have the same elements and same cardinality inside of the set. So that's why set A is an element of set B, because every element of set B is an element of set A. So, amo dyan talaw nato na equal set. So, we have here another example. So, if set M is 1, 3, 9, 5, negative 7, and for set N is 5, negative 3, negative 7, 3, 1, 9, then it can be stated that M is equal to N. Because same sa example number 1, we have the same cardinality and elements of inside of the set. So, did you get it? Alright, so now let's proceed to equivalent set. So here, kasi ma-confuse ka mo, what is equal set and what is equivalent set? So here, ato i-discuss kung what is equivalent set. So, if the cardinalities of two sets are the same, they are called equivalent sets. So, kaina sa equal set, they have the same cardinalities of the two sets, or set A and B. They have the same cardinalities, but they have also same elements inside of the sets. But here, matawag nato sila na equivalent set only if they have the same cardinality numbers inside of the set. So again, kung walang kita cardinality, it is the numbers of elements inside a set. Numbers, kung pila ka buok elements sa ilalim ng set. That's what we call cardinality. So here, if the cardinalities of two sets are same, they are called equivalent set. So to be equivalent, the sets should have the same cardinality. So again, the set should have the same cardinality of a set. Dapat same siya ng cardinality ng isa ka set para matawag siya na equivalent set. So it is stated here that this means that there should be 1-to-1 correspondence between elements of both the sets. So here, 1-to-1 correspondence means that for each element in the set A, there exists an element in the set B till the sets get exhausted. So I will present some example for you to be able to understand what is equivalent set and for you to know the differences between equal sets and equivalent sets. So example number 1. So if A is equal, if set A is equal to 1, 2, and 6, and for set B is we have 16, 17, so 12. So they are equivalent as cardinality of A is equal to the cardinality of B. So as you notice, sa set A, there are 3 cardinality of a set for the set A and as well as for the set B. So we have 1, 2, and 6, and for the set B we have 16, 17, and 22. Okay, mula kung kita cardinality again, it is the numbers of elements of a set. So here, for our example number 1, it is clearly stated that this example is an equivalent set because they have the same number elements inside of a set. Although they have different elements na nag-contain in both sets, but the number of their cardinality is equal. So that's why what we call the equivalent set. So naglaong diri na they are equivalent as cardinality of A is equal to the cardinality of B. So example number 2, set A is represent apple, orange, grape, and banana, and for B is we have W, X, Y, Z. So taglain sila ng tag-represent, but again, they have the same cardinality. So we have apple, orange, grapes, and banana, and for the B, set B, we have W, X, Y, and Z. So there are 4 cardinality of these two sets. That's why it is called equivalent set. So take note that the sets have the same number of elements in each case. Although the elements themselves may be different, this makes them equivalent sets. So again, the sets have the same number. These two have the same numbers of elements in each case. So although the elements themselves may be different, this makes them equivalent set. So, an element sa kadyo para matawag siya na equivalent set. So, if the elements of the set or the given set is not is different from the other sets, therefore, and the same cardinality or the number of elements inside of that set, therefore, the given example is representing equivalent set. So, kung same sila ng elements sa ilayom and same of cardinality, the given example or the problem represent equal sets. So equal and equivalent set are terms used to denote some kind of relationship between two sets. So you may think this as some sort of comparison, like how you would compare apples to orange, but if there is no standard by which we can compare them, then it will be very difficult. Of course, it would be very difficult to establish anything. So if we were to compare them by number, then we could say that there are more apples than orange, or vice versa, of course. Or we could say that there are equal members of apple and oranges. So the same way, if we were to compare two sets, we could use cardinality as a standard for their comparison. So, always remember the cardinality kay para dili ikaw malibog sa differences ng equal sets and equivalent sets. So, that would be my part, and I think this would be the last types of sets because I am the last presenters, of course. So, that would be all. Thank you for watching.